Okay, so now we want to talk a little bit about using power and how we're able to harness electricity. And the definition of a circuit, right, is a closed loop for the flow of electricity, right? So from a battery, it's a flow that comes to a load and then back. And from a power generation station, it's a push pull. But they both require a closed loop. Now, part of that is an open, we have switches just like your wall switch. And what that does is it opens that circuit and prevents the flow of electricity, thereby turning off the light. When you close that light switch, right, it allows that flow of electricity to a light bulb. Now, if there is not a light bulb, if there is a problem in the system and the send wire and the return wire accidentally come in contact with one another, it creates a short circuit. And a short circuit is dangerous and bad. What it does is it allows all of the potential power from a source, whether that's a generator or a battery, all of the potential power to flow all at once in an uncontrolled loop. And it makes all kinds of problems. It'll overheat, it can catch fire, batteries can explode. Their short circuit is bad. Whenever we have a load, the load regulates the amount of electricity that flows. In a short circuit, it's uncontrolled flow, right? And dangerous. So let's talk a little bit about household power distribution and protection, right? So we bring in the electrical service from the transformer, from the power pole into the house, right? And it comes down, right, through your meter, which is how they decide how much electricity you're using and send you a power bill, right? And then it comes into a distribution panel. And many of you may have seen this distribution panel in the house if you're using the toaster and the microwave all at the same time and suddenly they stop working. You find this power panel in your house and you reset this thing called a circuit breaker. And a circuit breaker is a protection device. If you're using too much power all at once, it wants to protect the wire and protect the equipment, right, from damage, maybe from catching fire. And the circuit breaker will trip, right, saying you're using too much power. You can go to the breaker panel and reset it. Let's talk a little bit about distribution in your home. Right? So you have this circuit breaker panel, and if you take the cover off, you'd see something that looks like this, right? To where all the different wires go into different circuit breakers. And these different circuit breakers feed different parts of your home. Some of them feed the lighting outlet or the lights overhead. Some of them feed wall outlets in different rooms or different sides of rooms, right? So each circuit breaker is running a different source, right, or a different outlet in your home, right? So there are different kinds of circuit breakers, right? We spoke about phases, right? And there is a two-pole circuit breaker. It will occupy two slots, right? And this breaker that occupies two slots then will have an A phase and a B phase, or a B phase and a C phase, right? It has two phases, right? And that's used for your dryer, for your stove, for your water heater. So anytime that you see a breaker that has one handle but occupies two slots, right? That's a two-pole breaker or two phases. Now, in industrial applications and in the light lab, we have some three-phase breakers. And this breaker will control all three phases, right? For an output, oftentimes it goes to a motor or another power distribution system. That's three-phase breaker. So you'll see that. Let's look a little bit about breakers, right? So tripped circuit breaker, a breaker that has been overloaded. There are typically two ways that indicate a tripped circuit breaker from an overload. One is going to be that you'll see that the switch is sort of halfway between its on and its off position, right? If it's in this unusual position, that means that it's been tripped. And in order to reset that, you would turn it to its off position and then move it back to its on. Now, it's important that you don't repeat whatever it is you were doing, i.e. the microwave and the toaster at the same time. It will trip again, but you don't want to do that. When a circuit breaker trips, it means that you've done something inappropriate and a safety measure has been engaged to prevent a fire or damage to your electrical system. So toast your toast and then wait for a minute and then microwave the water for your tea, right? Split up the task so that you don't repeat that problem. Now there's another kind of circuit breaker, and when it trips, it will also move to that neutral position, but it will also throw a flag that is either red or orange or deep amber. It'll put a little color flag in a window to indicate that that circuit breaker is tripped. The same thing though, if you'll move it to its off position and then back towards center to turn it back on. Right, so multi-phase power distribution. Right? So again, we spoke about a breaker that occupies two slots. It has a black wire and a red wire, A phase and B phase. Those go to a breaker and then that powers, or to a disconnect, and that powers your 240 volt water heater, right? Or 208 water heater, right? So this is two phases of power with a ground, and note that this does not require a neutral. The difference in potential between the black wire and the red wire is 208 or 240. Those are used interchangeably sometimes, right? To power the heating element in your water heater, right? So we look at a three-phase switch. You'll see that we have the black wire, the red wire, and a blue wire, the three separate phases of electricity that pass through. These are fuses here, and then this is our load, whether that's another distribution panel or a motor, and then we just have the ground. The ground wire is the one that passes through, that's our safety. Great, and so we'll talk about ground in the next video.